Hi, Ms. Barber here. In this lesson, we're going to learn some of the aspects of financing a car and maintaining a car. This lesson is called Costs of Car Ownership. Purchasing a car most often requires the mathematics of financing or borrowing some of the purchase price of the car. We will use the loan repayment formula to calculate the regular payment amount required to repay a loan. That formula looks like PMT equals, in the numerator, P times R over N, and in the denominator, 1 minus, and in parentheses, 1 plus R over N raised to the negative NT. Note, when you're paying debt down, you have a negative in the exponent. These variables stand for P, the loan amount. This is also called the present value. PMT is your periodic payment. R is your interest rate, expressed in decimal form when computing. N is the number of compounding periods per year. And for the purposes of this class, the number of compounding periods and the number of payments you make are exactly the same. T is time, also in years. Example, suppose you decide to borrow $28,000 for a new car. You can select one of the following loans, each requiring regular monthly payments. Installment loan A is a 4-year loan at 2.4% interest. Installment loan B is a 6-year loan at 3.6% interest. Find the monthly payments and the total interest for loan A. Loan A is the 4-year loan at 2.4%. To solve finance problems, we go in a 4-step process. The first is to identify the formula. Because you see monthly and payments, and we know that we are paying off a loan, we'll choose the loan payoff formula. Now let's identify each of the parts. The payment is what we're looking for. P is the loan amount, which was $28,000. R is the rate expressed in decimal form, so 2.4% is 0.024%. N is the number of payments you make in the year. Since it's monthly, it'll be 12. And T is the number of years, or 4. So let's put this together in the formula, and you get PMT is equal to 28,000 for the P. We put in 0.024 for the rate. We put in 12 for the N, that's the number of payments. And we put in 4 for T, the number of years. Now let's solve. We take the previous completed equation and we'll go step by step. Where you have 0.024 divided by 12, that's equal to 0.002. Let's do that computation. Where you have 12 times 4, that's equal to 48. Let's do that as well. And now let's look in the denominator in the parentheses where you have 1 plus 0.002. We'll add those two terms together, and we get that this payment formula is equal to 28,000 times 0.002 in the numerator, and in the denominator you will have 1 minus the expression 1.002 raised to the negative 48. That leads us to 28,000 times In the numerator, 0.002, and in the denominator, do 1 minus, because in your calculator, when you compute 1.002 to the power of negative 48, write down the entire set of digits you see on your calculator screen. On mine, I saw 0.908551167. Notice that I don't skip any steps. We'll continue. Get 28,000 times, the numerator is still 0.002, and in the denominator, when you perform the subtraction, the difference is 0.09144888833. Now we want to do that division of those two terms in the parentheses, and you'll get 28,000 times. The quotient is 0.021871413. Multiply that number by 28,000, and that's approximately 612.32639566. The monthly payment for Loan A is $612.33. Now, for the monthly payments associated with Loan B. The monthly payment for Loan B is $432.98. The complete solution for computing this payment is provided for you in your student notes. Let's compare the monthly payments and total interest for the two loans. We'll begin by finding the difference of the larger payment minus the lesser payment. In this case, it's the Loan A payment of $612.36 minus the lesser Loan B payment of $432.98. That difference is $179.34. The monthly payment is $179.34 less with the 6-year loan. That's almost a $200 a month savings. But let's see what happens. In Loan A, the total that you pay is your monthly payment times the number of payments. It's a 4-year loan. So you multiply 612.36 by 48. The product is $29,393.28. So the interest charged by Loan A is the total paid minus the amount borrowed. And that turns out to be $1,393.28. Let's see how much you pay with Loan B. You have the lesser monthly payment of $432.98, but the loan is for 6 years, so you make 72 of those payments. That means you end up paying $31,174.56 total for the 6-year loan. And so the interest charged is the total you paid minus the loan amount. The difference is $3,174.56. You pay less monthly with the 6-year loan, but a lot more in terms of overall cost. For a monthly savings of $179.34 and 2 additional years of payments, Loan B costs $1,781.28 more in interest and finance charges. Example, consider the following to answer the questions that follow. Suppose you're thinking about buying a car and have narrowed your choices to 2 options. The new car option. The new costs $25,000 and can be financed with a 4-year loan at 2.19% interest and has a monthly payment of $544.45. The used car option. The 2-year-old model of the same car costs $17,500 and can be financed with a 4-year loan at 3.90% and has a monthly payment of $394.35. Let's start with question 1. Identify the formula that should be used to solve for a car payment. What did you decide on? The answer is C. We're solving for a payment on installment loans. Question 2. For the new car loan, what is the interest rate R? The new car option, the interest is 2.19%. And so in decimal form, that would be B, 0.0219. 3. For the used car loan, how many total payments are made? The used car is a 4-year loan and you make monthly payments. So 4 times 12 gives us 48. Question 4. What is the difference in monthly payment between the 2 loans? Well, the new car loan's monthly payment is $544.45. The used car loan's monthly payment is $394.35. The difference, that is, you subtract $394.35 from $544.45. And that amount is D, $150.10. Next question. For the new car loan, how many payments are made? The new car is financed for 4 years. You make monthly payments, so 4 times 12 is 48. And question 6. For the used car loan, what is the interest rate R? The interest rate for the used car is 3.9%. So in decimal form, it is 0.039%. Question 7. What is the total interest payment for the new car loan? To do that, we need to find out the total paid, which would be $544.45 times 48. That product is $26,133.60. Now we need to subtract the loan amount. So you have the $26,133.60 minus $25,000. The total interest payment is that difference, $1,133.60. Question 8. What is the total interest payment for the used car loan? This one as well, we need to compute the total paid. That would be the monthly payment of $394.35 times 48. That's the number of payments. That product is $18,928.80. That's how much you end up paying for that used car. So how much of it is interest? That would be the $18,928.80 minus the loan amount, which is $17,500. That difference is $1428.80. So for question 8, the correct answer is D. Which is the better deal? You decide. Example, let's suppose you drive 18,500 miles per year and gas averages $2.10 per gallon. Part A, what will you save in annual fuel expenses by owning a hybrid that averages 40 miles per gallon rather than a vehicle that averages 22 miles per gallon? To solve this, we need to find the annual fuel expense. You do that by taking the annual miles driven and dividing miles per gallon times the price per gallon. Let's start with the hybrid. For the hybrid, you drive 18,500 in a year, divide it by 40 because that's the miles per gallon you get, and the gas is $2.10 per gallon. Compute that. The quotient gives you 462.5. Multiply that by 210. And the AFE, the annual fuel expense, is approximately $971.25. That is the product of the 462.5 times 210. Let's compute the annual fuel expense for a gas car. You still drive 18,500 miles in the year, but you get 25 miles to the gallon, and you still pay $2.10 per gallon for gas. Computing 18,500 divided by 25 is 740, and multiply that by 210. That product gives you the AFE. The annual fuel expense is approximately $1,554. Part B. If you deposit your monthly fuel savings obtained by driving the hybrid instead of the other vehicle at the end of each month into an annuity that pays 7.5% compounded monthly, how much will you have in that annuity at the end of the 10 years? We need to first compute the monthly fuel savings. So, to get the monthly fuel cost savings, we'll find the yearly first, which would be the $1,554 minus the $971.25, the difference of which is $582.75. That's how much you save in a year. And so monthly, take that $582.75 and divide it by 12. And that gives you $48.56. What we're going to be working with is an ordinary annuity here. You're going to make periodic payments for a length of time. So we will use the ordinary annuity formula, which is A equals P times, and in the numerator still, 1 plus R over N in parentheses raised to the NT, minus 1, and in the denominator, R over N. Let's identify those parts of the ordinary annuity formula. A is the accumulated account balance. That's what we're looking for. P, which we computed as our monthly fuel savings. That's 48.56. R is the interest rate, 7.5%. Express that in decimal form. That would be 0.075. N is the number of deposits you make in a year. That's also the number of times your account is compounded, and that turns out to be 12. T is the number of years total. You're going to do this for 10 years. Now we'll put this together into the ordinary annuity formula. You have A equals 48.56 brackets, open parentheses, 1 plus 0.075 for the R, divided by 12 for the N, close parentheses. In the exponents, 12 for the N, 10 for the T, minus 1 bracket. In the denominator, you'll have 0.075 for the R and divided by 12 for the N. Now let's start solving this. We work from the inside out. 0.075 divided by 12 is 0.00625. 12 times 10 is 120. With those computations, we've got it simplified a little bit more to 48.56, and in the numerator, bracket, open parentheses, 1.00625 raised to 120 minus 1 close bracket, and in the denominator, 0.00625. Continuing, in your calculator, key in 1.00625 to the power of 120 and write the entire expanse of the digits you see. On my calculator, I have 2.11206467 for that exponent. Let's continue. That would be equal to 48.56, and the numerator, subtract 1, so you got 1.11206467. That's still divided by 0.00625. Notice, no skipping steps. That's equal to the 48.46 and the quotient of the 1.112064637 divided by 0.00625 is 177.9303419. Multiply that number by the 48.56 monthly payment, and that's approximately 8640.297.405. The hybrid owner would have about $8,640.30 in his annuity at the end of 10 years.